All right, for this section of notes, guys, it's 7-3, similar triangles. Postulate 7-1 says, if the two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This is also what we would call angle-angle similarity. And you could write out angle-angle similarity, or you can just abbreviate it just like so for angle-angle similarity. So in the picture below, they tell us that angle P is congruent to angle T, and that angle Q is congruent to angle S. Whenever that happens, we know that these two triangles would automatically be similar by angle-angle similarity, okay? All right, for the next one, if an angle of one triangle is congruent to the angle of a second triangle, and the sides that include the two angles are proportional, then the triangles are similar. All right? Now, this is what we're going to call side angle side similarity. Now, if you recall when we did side angle side congruency, the angle has to be trapped between the two sides. Same thing here. So if we wanted to do this, we would say that A would go over top of AX, and that B would go over top of BX. So when we set it up as a proportion, that means we set it up as two fractions equal to each other, and then we would be able to solve using that. All right? 7-2. If the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. All right? This is what we would call side-side-side similarity. So this one, instead of having an angle involved, we're just going to do all three sides together. So you would do A would match AX, then we would set that to B over BX in this case, and then lastly C over CX, because those are the corresponding sides for the triangles. All right? So if you have all three sides that match up like that with proportions, then it would be side-side-side similarity. All right. Next one. Similarity of triangles is reflexive, symmetric, and transitive. All right, so let's review these properties a little bit. The first one here says triangle ABC is similar to triangle ABC. It says the same thing twice. That is what we call our reflexive property. For the second one, it says if triangle ABC is similar to triangle DEF, then triangle DEF is similar to triangle ABC. They flip the order around, so that's what we would call the symmetric property. And then the last one, if triangle ABC is similar to triangle DEF, and triangle DEF is similar to GHI, then triangle ABC is similar to GHI. If you notice, the DEF was repeated, so they got rid of it and just put ABC and GHI together with similar, so that would be our transitive property. All right, so we're going to use all of that information to help us solve for example 2 here. It says, find AE and DE. Note the parallel lines, figure out which angles are congruent, and set up a proportion. So guys, what you need to do is you need to make sure that these triangles are similar to begin with. The way that you're going to do that is you know that you can mark vertical angles. So there's one set of angles that we automatically know are congruent. Then, because we have parallel lines, we can also do our alternate interior angles, which would be like angle A and angle D, right? So if we have two angles that now match, we know that these triangles are similar by angle-angle similarity, which means we now can set up a proportion of our sides. So let's start with this. We know we have a 2 right here. So we need to figure out what matches 2 in the other one. Well, it's beside the 2, but it's not trapped in between, so that would match 5. So we would put 2 over 5. Then we need to match the x minus 1 with whatever's left over, or whatever matches it in the other one, which would be x plus 5. At this point, now to solve a proportion, we use our cross multiplication. So we're going to cross multiply and we get 2 times x plus 5. And it's best if you write it out this way because then you remember that you have to use the distributive property. And then on the other side of the equal sign, we get 5 times x minus 1. So let's go ahead and distribute that 2 in. So we get 2 times x, which is 2x. 2 times 5 is 10. All right. Do the same thing over here. 5 times x and 5 times negative 1. So 5 times x gives us 5x. 5 times negative 1 gives us negative 5. Let's start by getting our x's together. So we're going to subtract 2x. So we get 10 equals 3x minus 5. Then we're going to add 5 to both sides. So 3x equals 15. Last step is to go ahead and divide by 3 and x equals 5. Now, most people get this question wrong because they stop right here. That is not our answer because they wanted us to find AE and DE. Well, if we want to find AE, we know that AE is x minus 1, so we take the x out and put 5 in, so 5 minus 1, so AE would equal 4. All right? There's one answer. The second answer we want is to find DE. We know that DE is x plus 5, so we say 5 plus 5, so DE is going to equal 10. All right, and there's the two answers you're looking for. Let's try example 3 here. It says Nina was curious about the height of the Eiffel Tower. She used a 1.2 meter model of the tower and measured its shadow to be at 2 p.m. The length of the shadow was 0.9 meters. Then she measured the length of the shadow of the Eiffel Tower, and it was 240 meters. What is the height of the Eiffel Tower? So essentially, guys, what you're looking at, and this is one of the best examples that they use, or most common examples that they're going to use with this, is shadows to figure out from a model to figuring out something, or how tall a person is in relation to it to help figure out the height. So what we need to do is we need to fill in some information. So on the picture on the left, we have our model, which we know that she measured the shadow to be 0.9 meters, right? We also know the height of the model is 1.2, so we can fill that in. The next thing is we know the shadow of the Eiffel Tower was 240 meters, and they want us to solve for x. Now, what they're assuming that you know how to do on this is you should know that whenever we measure something with its height, it makes a 90-degree angle with the ground. So we know we have two angles that are congruent, right? And then if the sun's reflecting off or bouncing off of something and it hits the ground, then these two angles have to be the exact same. So now we know that these are similar by angle-angle similarity, and we can use the proportion that it gives us below. So we take the height of the Eiffel Tower. The height of the Eiffel Tower is x, so we'll put that there, over the height of the model, which is 1.2. Then we're going to set that equal to the shadow of the Eiffel Tower, which was 240, over the shadow of the model, which was 0.9. From here, we just cross multiply. X times 0.9 is going to give us 0.9x equals 1.2 times 240 is 288. Once we have that, we just now got to divide by 0.9. 288 divided by 0.9 would give us 320 meters would be the height of the Eiffel Tower. All right? So make sure that you come into class with these completed, and see you next class.